All right, so we continue with Bitcoin and we are going to talk about forks. Of course, forks are a generic topic for every blockchain, and we will give the general idea and then talk a little bit about forks that happened in Bitcoin. So changes to a blockchain network's protocol and data structures are called forks. A soft fork is a change to a blockchain implementation that is backwards compatible. So non-updated nodes can continue to transact with updated nodes. A hard fork is a change to a blockchain implementation that is not backwards compatible. So this causes a problem. And actually here you are dividing the blockchain into two different blockchains when you create a hard fork. It is important to note that while most hard forks are intentional, software errors may produce unintentional hard forks. So this generally happens in Ethereum-like blockchains because a smart contract, generally, people create different software to interact with Ethereum, and a smart contract should run in the same way and should provide the same output in every node. So if your software has some bugs, then that smart contract might give some other results in software that has bugs, then this would cause a hard fork unintentionally because the output is not the same. So with cryptocurrencies, if there's a hard fork and the blockchain splits, then users will have independent currency on both forks. This is one of the things people prefer. This is also one way of creating a new alternative currency. Because if you create a new cryptocurrency, you should advertise it and you should invite people to use it. But if you hard fork a non-blockchain like Bitcoin, then at that point, everybody who has Bitcoin also has your also has your cryptocurrency with the same amount, right? So this way you can already have customers, let's say. If flows are found in cryptographic technologies within a blockchain network, the only solution may be to create a hard fork depending on the significance of the flow. So this happened again in the past. Some alternative cryptocurrencies have some bugs in their mining algorithms. Their cryptographic hash algorithms are implemented in a wrong way. So they have to change these algorithms in order to cryptocurrency to work. So this created hard forks. So if you modify this kind of cryptographic algorithms that are run in the background, you have to create a hard fork. When a recommendation is made for a significant upgrade that will cause either a hard fork or a soft fork, miners simply have to change their version number in mine blocks to the new version number or leave it as it is. So this is how you understand if people are really supporting your update, okay? So then generally this is what happens. For instance, when you decide to create a soft fork, for instance, for Bitcoin, you create the patch. Now the version number is the new version of this new patch, but the update will become effective maybe 5 months later. So during those 5 months, you look at the mined blocks and see the version number of the miners and see which percentage of the miners actually accepted this new upgrade and who remained behind. So this creates a sort of vote and will either confirm or reject the proposal. The 2015 soft fork that brought in BIP66 had 95% of the miners hashing power in agreement to change their block version to 3. So this way you knew that people upgraded their software. So a soft fork has actually 3 outcomes. First, the miners all agree and the fork isn't really a fork, just a software change. Second, a majority of miners agree, the new fork sticks and the old fork slowly dies. So those people then say that, okay, this fork dies, so let's move on to the upgrade and keep working with the other people. Or a majority of miners disagree and the new fork dies. Okay, this is what happens with soft forks. So the SegWit upgrade, the soft fork is really, really important, and there's a very nice documentation at this link. I strongly recommend you to read it. So the title actually explains it all, The Long Road to SegWit. how Bitcoin's biggest protocol upgrade became reality. So initially, it was very hard to convince miners to make this upgrade. So developers tried this for years and they couldn't succeed. They met with the owners of the biggest pools. They met in China, they met in other places, they agreed, but they still didn't upgrade it, okay? So it was very hard to convince these people because what the miners actually wanted is that to increase the block size, okay? But increasing block size would cause a hard fork, and Bitcoin developers so far avoided creating hard forks. They tried to solve the problem with soft forks. So again, as I mentioned, the SegWit actually, takes the signatures from the transactions and puts at the back. So this way, the 1 megabyte block size actually virtually increased to 4 megabytes because now you're not counting the signature sizes, which are the biggest parts of the transactions. But miners didn't upgrade their software, so it delayed this upgrade for like 2 or 3 years. But they, at the end, agreed to upgrade for a completely different reason. And that reason was that since everybody are using ASICs, there was a trick that you can do for these ASIC devices, which would boost your performance 20%. So in that scenario, you actually calculate hashes before having the transactions in that order, then resolve it. So this actually created an uproar because everybody were, for instance, using the same hardware ASICs, but some people make a small trick and increase their performance 20%. This upgrade actually prevented that trick. So this is why actually miners said that, okay, we are installing this upgrade. But after that, when we look at the recent Taproot upgrade, it turned out that it is no longer that hard, and new abilities are actually now welcomed by the miners. And actually, this kind of things create hypes and increases the prices and so on. So SegWit, which is short or segregated witness, moves all of the signature data in a Bitcoin block to the end, lumping the signatures of all transactions together. SegWit solves the malleability bug, which is not much of a problem, but makes it significantly harder to build certain second-layer protocols on top of Bitcoin, like bidirectional payment channels. This allows more transactions to fit in the same amount of space while maintaining the security of the Bitcoin blockchain. SegWit increases 1 megabyte block size virtually to 4 megabyte. Again, it is still 1 megabyte. So the transaction sizes in total cannot exceed 1 megabyte, but with the signature sizes, they actually, exceed 1 megabyte. That is the idea. So this is a very nice thing. So if you simply change this 1 megabyte to 4 megabyte, this will create a hard fork because you will be modifying the main specifications of the Bitcoin. So actually other people did that, increased to 8 megabyte and created another cryptocurrency, but that would be a hard fork, right? So SegWit is a technique that reduces Bitcoin transaction fees because now the transaction sizes are smaller. So let's move on to more recent upgrades. This is Taproot. So after 4 years, Bitcoin received another upgrade since the SegWit. So this created a huge hype. So the Taproot soft fork introduces the concept of Merkleized abstract syntax tree masked and Schnorr signatures to improve the scripting capabilities and privacy of the Bitcoin network. Okay. So the Bitcoin network successfully activated the Taproot soft fork following a 90% lock-in consensus from miners and mining pools between blocks this and this. Okay. So after the introduction, just 1 month later, we realized that there are like 90% lock-in. So we realized that although the so when you create an upgrade, you say that at which block it will become effective. So by calculating the 10-minute block size creation, you would easily notice that Taproot upgrade will become active around these dates. So actually, it became effective on 14th of November. So people who knew this actually, earned a lot of money, by the way. So, but before that, I think the upgrades announced in May. So around June or July, we had 90% lockdown. So compared to November, we knew that it was going to happen. The milestone signifies the first major upgrade for Bitcoin since August 2017, which saw the launch of Bitcoin's leading layer 2 solution, the Lightning Network and segregated witness. This mask that I mentioned, Merkle's abstract syntax tree, can be used to compactly represent contextual programs that will be executed remotely. And by using some of the properties of Merkle trees, they can also be used to verify the integrity of the code being executed. More on this you can read on this report. Again, these new abilities are slowly understood and then used in practice. So let's look at the Schnorr signature scheme, which became effective after the taproot. So let's briefly look at this Bitcoin BIP 340. So Bitcoin has traditionally used elliptic curve digital signature algorithm signatures over the famous SECP256K1 curve with SHA-256 hashes for authenticating transactions. So elliptic curve digital signature algorithm has a number of downsides compared to Schnorr signatures over this elliptic curve. So the thing is that Schnorr signatures also use this elliptic curve, okay? So there are two different algorithms using the same elliptic curve. Both of them are signature algorithms. But the downsides of the elliptic curve digital signature algorithm was the provable security. Schnorr signatures are provably secure. In more detail, they are strongly unforgeable under chosen message attack. So if you're interested, you can look at this public key cryptography concepts. Another one was non-malleability. This strongly unforgeable under chosen message attack security of Schnorr signatures implies that they are non-malleable. On the other hand, elliptic curve digital signature algorithms signatures are inherently malleable. A third party without access to the secret key can alter an existing valid signature for a given public key and message into another signature that is valid for the same key and message. This issue discussed in these BIPs. So currently it is not a direct attack, okay? So assume this thing, so somebody signs a message, so you create a valid another signature, but this is also for the same message. So you might think that, okay, this doesn't cause any problem, right? Because somebody signed it already. So assume it like this. So I have white paper, let's say in physical world, I'm signing something. But somebody creates a yellow paper, which also says that I signed the same message. So physically, there are two different things, right? But I'm signing the same message. So in theory, this shouldn't cause a problem. But in practice, this might cause a problem because those light nodes who doesn't store the signature themselves might be, misguided at the end. Linearity, this is the important thing, and this is the thing we will talk about when we talk about multi-signatures. Schnorr signatures provide a simple and efficient method that enables multiple collaborating parties to produce a signature that is valid for the sum of their public keys. So in elliptic curve digital signature algorithm, when you need a multiple signature, for instance, assume that 5 people get together and sign a transaction. This causes a 5 signatures in elliptic curve digital signature algorithm. In the Schnorr signatures, those 5 people somehow combine their secret keys, and it turned out as if it is a single secret key, and then sign the document. So this way you end up with a single signature, which is valid for all of them. Okay. So let's look at the hard forks. As I mentioned, Bitcoin developers avoided hard forks, but some other people created hard forks, and there are many hard forks for Bitcoin in the past, with intentional hard forks done by other people. So Bitcoin developers so far avoided hard forks. They went great lengths to turn SegWit into a soft fork. As I mentioned, 1 megabyte block size turns into 4 megabyte, but with a soft fork. That is a very clever thing, by the way. Many people thought that instead of SegWit, Bitcoin's scalability problem should be solved by a hard fork that increases the block size. So on 1st of August 2017, a hard fork increasing the block size to 32 megabytes resulted in a new blockchain called Bitcoin Cash. So at that point, if you had 10 Bitcoins, now that you owned 10 Bitcoin and 10 Bitcoin Cash. So the question was, which of these blockchains will be more famous at the end. So people think that since the original Bitcoin created by Satoshi, they thought that more people will be there. So at the time of this hard fork, people who knew this sold their Bitcoin Cash at a very high prices and then bought Bitcoin back. So you can look at the Bitcoin price of, the price of the Bitcoin Cash, and you will realize that initially it was as high as that times Bitcoin prices and dropped significantly in 2 or 3 days. So it was a nice way of earning money also. So since the block size increased, Bitcoin Cash provides 200 transactions per second compared to like 5 or 6 that we mentioned before for the original Bitcoin. But Bitcoin Cash itself later went through another hard fork to increase the block size to 128 megabytes when Bitcoin SV split off on 15th of November 2018. Anybody having M Bitcoins before the split also has M Bitcoin Cash after the split. So that is the idea about this kind of hard forks.